Question number 4. This question is of kinematics of motion, and in this question, concept of differentiation and integration lies. A particle P moves in a straight line. It starts from rest at point O on the line, and at time t second after leaving O, it has acceleration a. Acceleration a meter per second square, where a is equal to 6t minus 18. Find the distance of P. Find the distance P moves before it comes to instantaneously at rest. Let this is point O from which it starts. Moving on this side, initial speed will be 0. Find the distance of P. This is particle P. This particle is particle P. Find the distance P moves before it comes to instantaneously at rest. Suppose at this point it is at rest. Now, given acceleration time relation is given, A is equal to 6t minus 18. First we will find the speed, because speed is 0 at this point. We have to find the speed from this relation. This is acceleration time relation. We will integrate each side to find speed. So we are integrating. When integrating acceleration with respect to time, we get speed. So we write here v, integrating right side with respect to t, v is equal to 6t square over 2 minus 18t plus c. This c is a constant of integration. Simplifying, we get v is equal to 3t square minus 18t plus c. Now we will find the value of this c by using initial conditions. When it starts, since it starts, the particle starts from rest, so speed will be 0. V is equal to 0 when t is equal to 0. So when we will put these two values, v is equal to 0, t is equal to 0 in this relation, we get c is equal to 0. C is also 0. So this relation become speed will be 3t square minus 18t. And now we have to find the distance. And now we again integrate this relation, speed time relation. This is a speed time relation. We will integrate to find distance. Uh, Integration of v with respect to t, we get distance. Right side will be integrated with respect to t. So integrating, we get s, integration of right side with respect to t. We get distance is equal to 3t cube over 3 minus 18t square over 2 plus c, again c will be here, constant of integration. Simplifying, we get t cube minus 9 t square plus c. Again, we will use here initial conditions. When t is equal to 0, no distance covered, so s is equal to 0. So putting these two values, t is equal to 0, s is equal to 0 here, we get c is equal to 0. C is equal to 0. So distance will be t cube minus 9t square, t cube minus 9t square. Now at this point, we have to find this distance where the particle is instantaneously at rest. We have to find this distance. Here the speed is 0. So putting this speed equal to 0, we can find the time. Speed is this 3t square minus 18t. We are putting it 0 since v is equal to 0. So uh, 3t square minus 18t is equal to 0. 3t is common, t minus 6. We get here from here two values of t is equal to 0 or t is equal to 6. These two values shows that t is 0 here and t is equal to 6 is here. T is 0, that is at the starting point, and t is equal to 6 at this point where the particle instantaneously at rest. So we will use this t is equal to 6. So this distance will be uh, t cube minus 9t square. Putting this value of t, we get s is equal to 6 cube minus 9 into 6 square. After simplifying, we get s is equal to 216 minus 324. So s is equal to s is equal to uh, 216 minus 324. We get minus 108. But we will take its magnitude only. S is equal to 108 meter. This is the final answer.